All right, we're going to start off here with some properties here. So first of all, we have the commutative property. So the commutative property says that when we add or multiply two numbers, order does not matter. Or I'll go ahead and go with the contraction here. It doesn't matter. Okay, so for example, I think most of us know if we have like 5 plus 6, then that's the same as 6 plus 5. And it works for multiplication as well. So we could say 6 times 5 is the same as 5 times 6. All right. It also works for variables. So we know that x plus y is the same as y plus x. Probably something you guys already know, but just a quick reminder that that is because of the commutative property. All right, next one is called the associative property. So this is about adding and multiplying again. It is adding. So when we add or multiply three numbers, it doesn't matter which two we add or multiply first. So kind of a similar one here. But once again, dealing with three numbers. So this one would be like if I had parentheses 2 plus 5 plus 6, that would be the same as 2 plus parentheses 5 plus 6. You can probably do the math in your head there that the first one comes out to 7 plus 6, which is 13. And the second one comes out to 2 plus 11, which is also 13. So this also works for multiplication. And so we could say that parentheses 2 times 3 times 5 is the same as, and I'll have to write it down here. If you have more space, you can write it there, but 2 times 3 times 5. And so if you kind of did the first one, let me get my lightsaber pointer here. So you did the first one, so 6 times 5 would give you 30, and this one would be 15 times 2, which would obviously also give you 30. All right, last property we're going to go over here is the distributive property, probably one you know well. It says when we multiply a number by the sum of two numbers, we get the same result as multiplying the number by each of the numbers. Then adding them. So for example here, you guys probably know something like 2 times, 5 minus 3 is the same as 2 times 5 minus 2 times 3. Now we did say addition there, but it does work if there's subtraction inside of the numbers. And so, because subtraction is really just adding a negative. So you can see here, this one, if you did PEMDAS, would be 2 in the parentheses times 2 is 4. And this one would be 10 minus 6, which is also 4. Another thing on this one, though, whenever we do FOIL, so if you have like, x plus 2 times x minus 3, what we're supposed to do, you probably learned FOIL here, so first times first is x squared. Outer times outer is negative 3x. Inner times inner is positive 2x. And then last times last is negative 6. This is actually also distributive property. I think of it like a double distribute. So you can see we're like distributing this x into that parentheses, and then we're distributing the 2 into that parentheses. We kind of do them both. And so that is actually another example of the distributive property. One I wanted to add up in the commutative property is this one that a lot of students get confused by. So if I had 2 times, let's say like x plus y, and then I rewrote it as x plus y times 2, a lot of students would say that's distributive property, but if this is what it's equaling to, over here, then you can see that I didn't actually distribute the 2. I just rearranged the order of 2 things. Now the second thing was this whole x plus y parentheses, so now that's first. And now the 2 is second. So that's kind of one that people often get tripped up on, is the commutative property, because it's really just the arranging of 2 things. Last thing on this page, I just wanted to kind of point out a little trick I use to remember the commutative property. So the commutative property, I think of the word a lot of adults use, that is commute. And so commute is like when you drive to and from work. So I always say, like, okay, so it's 2 things. You start at home, and then you go to work. And then at the end of the day, you start at work on your drive, and then you go home. Most people take the same route home as they do to work. They go the same route, kind of just in opposite directions. Not everybody, but probably most people. And so I just kind of remember that kind of going from home to work, you're going to take the same route as if you go from work to home, just kind of in reverse. So that's how my little trick to remember the commutative property. Think about the commute between 2 things and just changing the order. All right, next up here, we'll do some evaluating absolute values. So the big idea of absolute values is that it turns a negative number positive, and it keeps a positive number positive. So on number 9, the absolute value of 50 would just be 50. It's going to keep the positive number positive. And on number 10, it's going to turn the negative number positive, so we're going to get 30 there as well. Number 11 and number 12, I wanted to include these because this is often confused, and that is that although absolute values turn negative numbers positive, they do not turn subtraction into addition. So I cannot just turn that into 2 plus 5. What I need to do is think of the absolute value kind of like parentheses. I need to do the operation in there. So this is going to become negative 3 inside the absolute value, which I just got by doing 2 minus 5. All right, and then if I do the absolute value of negative 3, that's going to become 3. So you can see if I just change it to 2 plus 5, that's going to be 7, and that is incorrect. So that's not how we should be thinking about absolute values. Just think of it as just do the operations inside first, and then if it's negative, turn it positive. So same idea on number 12. So 5 minus 2 is 3, and that would be still inside the absolute value, and then the absolute value of 3 would obviously be 3. So the reason I put these 2 back to back is that you can see here that when we talked about the commutative property on the last page, we learned that that's only for addition and multiplication. So usually subtraction is not commutative. So 2 minus 5 is not the same as 5 minus 2. But I would say that for when it's inside of an absolute value, then subtraction actually does become commutative. And so with both of these, the kind of trick that we're going to be doing going ahead to number like 13 and 14 is anytime we have absolute values, we can actually always write it without the absolute values by just doing the bigger one minus the smaller one. And so we know that the result of an absolute value is always going to be positive. So if I always do the biggest minus the smallest, it's always going to come out positive because a big number minus a small number will come out positive. So that's what I'm going to do here on number 13. And so I'm going to ask myself, like, what's bigger, 3 or radical 3? And I think it's pretty obvious that 3 is bigger. If you want to kind of think of 3 as a radical, it would be radical 9. So then obviously that's bigger than radical 3. So I can just write this as the bigger one, which is 3, minus the smaller one, which is rad 3. And I can write that without the absolute value because I already know that that's going to come out positive. So then same idea for number 14. So I've got to think here, what's bigger, pi or 7? So obviously 7 is bigger. I think pi is about 3.14. So 7 is bigger. So when I rewrite this one, I do have to change the order to 7 minus pi because now I know if I write that without absolute value, the answer will be positive anyway. So it's just the same answer as the other order around, except I know this one's going to come out positive, whereas pi minus 17 is going to be negative. I'll skip number 15 for now, so 16 is kind of the same idea here. Remember, 8 is really radical 64, and so I need to change the order here to have the radical 65 first, and then I will go ahead and put the 8 second since I know that's smaller. Since I'm going to write this without the absolute value, I know that answer will come out positive. Okay, so you can see the only one out of those 3 that we did not change was number 13 because the bigger number was already first. So that's kind of the big idea there. All right, next one we're going to do is number 15. This one, we just have to work inside out. So it's like an absolute value within an absolute value. So I need to do the innermost thing first. So that's this absolute value of negative 5. I cannot turn minus minus to plus plus there because of that. The absolute value is kind of inside of there. So I'm just going to take care of this first, and obviously the absolute value of negative 5 is just 5. And then I'm going to keep everything else the same. So we're going to do 4 minus 5 inside of an absolute value. And so I just kept the 4, I kept the negative, I just changed the absolute value of negative 5 into a regular 5. Now I need to do the subtraction, so 4 minus 5 is negative 1. Inside of an absolute value, though, is going to turn into positive 1. All right, number 17, once again, just got to work my way through it. So I got to do the subtraction in the numerator first, which is negative 9. Subtraction in the denominator is positive 9. That's still inside of an absolute value. So when I divide those, it's going to come out to absolute value of negative 1, which is obviously 1. Number 18 is kind of like the ones we did where we need to do big minus small again. So I need to think what's bigger. Is it 7 or rad 35? Well, we know 7 is really radical 49. And so that is bigger. So I'm going to keep that first and keep the rad 35 second. So there we go. And then lastly here, I got an absolute value inside of there. So I'm going to say I'm going to keep everything else the same and just change that to a regular 3 now, since that's the innermost absolute value. I never want to distribute a negative into its inside of an absolute value, so I'm not going to do that. I'm just going to go inside the absolute value. Think of those kind of like parentheses now. So 3 minus 2 is obviously 1. And then absolute value of 1 is 1. And so I'm going to keep the 5 minus there. And so the final answer here would be 4.